Okay, good morning everyone. Can you all hear me okay? Oops. That's fine. Good morning. How are we all doing? Someone said busy for week 5. I feel you. Good morning, good morning. For those of you who weren't here on Monday, I'm Jake. I'm just taking the lectures this week for Sasha. For those of you returning, welcome back. We've got Tom Killing back again, helping us out in the lecture chat today. Thank you, Tom. Cool. Did everyone get a chance to watch Monday's lecture? If you weren't here, I guess, live. Oh no, I don't have any water today. That's not good. I'll have to get some later. So who had a chance to watch Monday's lecture? How did we feel about it? That's fine. No thoughts. No thoughts. Lecture was awesome. Thank you. Well, that's always good. Okay, so we'll just get straight into it. Basically, today we can be a little bit flexible, right? So the one thing that we want to do is to do basically a bit more code writing with 2D arrays. However, I also appreciate that we just introduced pointers yesterday, and so some of you may be trying to still get your head around pointers. So we can do a bit of a recap on pointers, sort of just talking about it conceptually. There might be a few of you who still haven't seen Monday's lecture yet. I'm not sure how many of that of you that would apply to. So, I'm happy to throw it to you guys. We can basically just do some code writing and build a bit of a bigger project. Where can we get the slides? That's a great question. How do I... give me a second. Okay, I'm going to send these to Tom, and Tom's going to... yeah, Tom's going to fix it for me. Thank you, Tom. I can also try this. Let me, guys, know if this works for you. Let me know what this does. There should be a link to the actual presentation, but I don't know what it'll look like on your guys' side. So, but the PDF will come as well. Okay, so why don't we do a quick poll? We happy to do that? Start a quick poll. How do we want to start off? We can do pointers, recap, concepts, pointers, code, recap, the walkthrough of Monday's, or we can go 2D array program. I really like it when you guys get to decide, some of the parameters of what we do. Let's see. Okay, most of you are saying some pointers recap. Yeah, by far. So let's do that first, but maybe only 20 minutes or so. some concepts we want to go over. Okay, we can do that. We can do that for sure. All right, why don't we do it all in a whiteboard? Let's end the poll. Let's do some pointers recap, and then we'll get into the 2D array program. So let's see how this is going to work. Huge. So pointers are a variable which store a memory address. So this is the first sort of point. Well, okay, let's maybe not say that. Pointers are a memory address. They refer to a location in RAM, memory. That location stores actual data, like an int, a struct, a double, or it could actually be another pointer. We don't know. It could be anything, right? It's just a reference to memory. We can store these memory addresses in a variable too, like any other variable. All right, so these are just some sort of facts about. Can you read this? Can you see this? Does it look okay? Yep, that looks good. Everyone can read it. You don't understand? That's okay. We haven't gotten started. You thought pointers are a variable. You thought. Let me keep talking and then we'll discuss SB. So you might actually be, well, they definitely store a memory address, but you might actually be right that yeah, okay. You're sort of right there. I don't know if this is what you're alluding to, but pointers are a variable which stores a memory address. Their value refers to a location in RAM. That location stores more data. Let's say this. Memory addresses like any other variable. Okay, this is a little bit more refined, I guess. So basically, just like you can have, you know, why is everything so? Maybe I just need to, hold on. You know, my age could be 3. So just like we could have this integer variable here, we could have another integer variable here, and we can also have my pointer, which stores a memory location, which may actually point to another variable. And again, let me know if you can't read this. What's important here is that let's get sort of our, if we call this our memory, here's a really nice way of sort of describing what's going on. Let's just do this. Oops. Oh, it's because I haven't, you know. this could be like the mouse X position. This could be like a different value. So what I want to sort of just clarify to everyone is that memory is basically a series of locations, right? Addressable locations, and that location may or may not have data. So think about variables in C as a memory location and a value that's at that memory location. So in this case, at the location 0, 0, 0, 0, we have an integer that's storing the value 3. Now, in actual fact, like in the memory, we don't know what the identifier of that variable is, but just to make it, for us discussing, we'll have the actual variable name in the boxes too. So we can have a couple of integers. What a pointer is, this is the new thing we're talking about today, a pointer. It doesn't store an integer or a double or a string or a character or a struct. It just stores one of these locations. That's basically all it is. And if it stores a location, C, the C programming language, gives us the ability to follow that location to an underlying value. We can follow the pointer. So Ayush is saying, so the pointer stores 0, 0, 0, yep, of the address of the age variable. Absolutely right. That's absolutely right. It's storing the address, pointing somewhere else. But what's critical here is that this pointer itself is a variable. And what that means is it also has its own address, right? That's the location that we're calling 0, 2. But the value of that pointer is 0, 0. And that's basically all a pointer is. And we just have some syntax and language structures in C that help us create pointers, follow pointers. That's sort of unique to pointers because if you have an integer, you just have the integer, you have the value. There's no need to follow that value. But if you have a memory address, there's things you want to do with that, like follow the value to the address. And also what's kind of cool and maybe sometimes confusing, we've got this new variable called second pointer. It can point to, another, it just points to memory. What's at that location? Another pointer. What's at that location? An integer, right? We can construct and manipulate these pointers sort of as we need to. How's that sitting with everyone? Is the X in the address a character? Okay, Nick, good question. No. Memory addresses are hexadecimal and they're represented usually in this sort of format. So 0, if you saw the Monday lecture code, we actually printed some real memory addresses. They're not this, they're usually a bit longer, and it's just identifying that it's a hexadecimal value. Dot says, can we go through the lecture code for pointer? Yes, we can go through it, but we do need to allocate time for the 2D array code. SB says, practically speaking, when would it be useful to point to another pointer? Okay, it's a little bit out of scope to discuss it at this point in the course, but there's a few times where it's useful. I'm just trying to think of like a nice simple way to explain it, but it's when you want to pass in to a function a memory address, right? A pointer in which we want to actually change what that memory address is. And if you pass in any value to a function in C, you get a duplicate of that value. So if you change that value, even if it's a pointer, it won't be updated in the calling function. So if you want to update the location, the value of a pointer, you need to pass in the location of that pointer, which would be a nested pointer like this. So basically, you've got some code in main, you've got a function that changes a pointer's location. You can't pass that pointer in because if you change that pointer itself, it won't get updated in main, so you need to pass up the memory location of the pointer, and that would be a pointer to a pointer. But you absolutely aren't expected to understand that yet. Goldleaf says are array pointers. They're very tightly coupled in C. There's a strong relationship between pointers and arrays. They are sort of the same thing. An array is basically a pointer to the memory address where the array starts, and so a little bit of extra stuff. But you're really, really good to spot that out. Nice work. James Smith says, can you make an array of pointers? Absolutely. It's actually really common. And a lot of really important data structures, like a hash map, I think, are based off that concept of an array of pointers that point to other memory locations. And each value may point to different memory locations. But yeah, absolutely we can. The thing about C is we can pretty much do anything, which is why it's such a cool language, and it's why it's such a dangerous language. Okay, but this is the general concept. All memory is addressable. Okay, the addresses are spaced evenly apart. Some memory, some values in memory will go more than, they might take up more data. For example, if this could be an array or a struct that's quite big, right? So, it doesn't look like a nice little grid or anything like that. It might look something like this, but all memory has an address in C. Oh, sorry, not in C. Every computer's memory is addressable. When you ask for a variable for some data, the operating system tells the program the location where it gets given some memory, and then it can just put some data in there. So SB says, if we make a pointer to an array, can it only point to the one entry or can it point to the whole array? Really, really good question. We'll talk more about this later in the course. Really, really good question. Let's say that, basically you point to the first element of an array and that's sort of it. The problem then is how do you access the other elements? And that's why you always need to pass in the size of the array. SB, so if some variables have multiple addresses, which one does the pointer take? So a pointer variable only ever has one value, like one pointer, and its own address. Like here, there's only ever one memory address in this pointer, right? A pointer points to one memory location. So a variable, unless you create some custom data structure that has multiple addresses, it only has one. So if you follow it, you're going to follow the value. You're going to follow this value. Oh, I see. And remember, this would be something else. So the pointer always points to the first. Great question. Great question. It's the first. It's like that. If that makes sense. It's always the first location that you would pass around. Because basically you get past this location here, and then by the data type how big it is, so you know where it ends. It doesn't make sense, to pass the middle and then go back and forth or something weird like that. Although I'm sure someone's done it for some arcane reason. Really good questions, everyone, though. Really, really good questions. But this is the concept, okay? If we ignore all the syntax and all the functions that we use to handle pointers, this is really simply the concept. Memory is an address and a value. A value could be a thing, like an integer or a double or a struct or a string, but it can also be a memory address. And it's a really, really powerful thing to treat memory as data in our programs, because that means we can really dynamically do lots of things that we couldn't otherwise do. It's also the basis of most important data structures, like binary trees, linked lists, hash maps. They're all based on this idea that if we treat memory location as data and we can manipulate that data and pass it around and change the values and change what's being pointed to, we can create some really cool things, some of which we're going to create later on with Sasha in COMP1511. So you'll be doing a lot of linked list stuff. Okay. Are we happy to leave it there? We'll look a bit of the Monday pointer code. Are we happy to do that? And then we'll get on to today's stuff. So let me just do this, blah, blah, blah. I just want to make something a bit bigger here for me. Okay. I'm taking up a lot of space today. Let's fix that. Let's close that. Is this looking nice? Looking clean? I love this Visual Studio Code theme. I really like it. Okay. So here is the lecture code. Maybe I'll make it a bit bigger. Is that better? Here is the lecture code that we wrote on Monday, doing some basic pointers stuff. The tricky part about pointers is the syntax, I think. And maybe what I can actually do, if you guys want, you let me know, is put some of the syntax in this thing and in this document and turn it into a PDF. So it's a bit like a reference cheat sheet. So if you want that, just let me know in the lecture chat. So there's two really important symbols in C when it comes to manipulating and creating and handling pointers, the asterisk and the ampersand. It's really unfortunate, I said this on Monday, but the asterisk has multiple meanings depending on its context related to pointers. So if you're declaring a variable and you put a pointer after the type, it means that you're declaring a pointer to that type. So something that I didn't mention in the diagram is that you always need to know, well, you don't always need to know, but it's very helpful to know the type of the data that you're pointing to. So in this case, you want to know that you're pointing to, you want to know that you're pointing to an integer so that you know when you follow it, how to read that data. You want to know here that you're pointing to a pointer so that when you follow it, you know that how to read that data. So you give it a type and you give it an asterisk, which means it's a pointer to that type, not a value of that type itself. So for example, my int with an asterisk here is telling the compiler, hey, we want to point it to an integer. So that's the first important piece of syntax. The second important piece of syntax is the ampersand. This means if you put it in front of a variable that you have, the ampersand means don't get the value of that variable, get the address of that variable. So again, if we go back to this diagram and I have the code, if I have the code, for example, ampersand mx, what's that going to equal? Can you all tell me? Yeah, fantastic. So not 50, Ayush, not 50, right? So yeah, you corrected yourself. So mx is 50. Ampersand mx, whoops, is 002. It's the address of a variable, right? So you just go up and you get the address. So, sorry, what have I done? It should be 1. Why did I do 2? No one said 2, did they? Yep, awesome. Yep, that was my mistake. Yeah, 001. So whatever the variable is, get its address. That's what the ampersand does. Right, so did you guys want that? Did you want me to turn this into a bit of a cheat sheet? No one actually... You gotta respond to my... So ampersand is the address of operator, which means does this make sense? So that means that if mx was to equal 50, ampersand mx is going to equal 001. That's that one. What else do we have? We've got the asterisk. at declaration means make a pointer. Let's do something like this. So that means if I go int x equals 5, that's fine. Int star x, whoops, is not going to equal, 5. It's going to equal a memory address. Something, we don't know what that address is going to be. But star x, it's saying I don't store an integer, I store a pointer. And then we have just one more construct. So int star x will be the address of x. Not quite. It's saying make a pointer that points to an integer. So what this does, if maybe this will help. Let's do like a to show that there's a lot more memory in the memory. Something like this. This makes, blah, blah. Sorry, that's not true. So what this does, right? And then I wanted to just so it declares a pointer, right, at some random memory location. We don't know what the operating system's going to tell us. In this case, I've just said 21. But the value of that pointer will be what I tell it is. Tell it is. In this case, 413 AC or whatever. Right, these are all just made up sort of addresses. You don't need to give it the pointer, just like you don't need to give, you don't need to initialize an integer to 5, right? But it's just saying, go off and make, maybe I can show that. Maybe I can, if I just did this, for example. It's going to go off and do something like that. Right? Does this make sense? Okay, how to make a pointer to a pointer? Oh, very, very good. I mean, again, we don't really need to cover this. I'll just put it here and then delete it because I don't want to make this too confusing, but pretty simply, you can just do that. This would be a pointer to an integer. Great question though. But I'm going to delete that because I don't want it on the cheat sheet for everyone that looks at it later. Okay. Nick says, so scanf %d mx, and I think you mean ampersand mx, is that right, Nick? Means change the address of mx from this. Oh, well, yeah, you would be right if you typed in 50. And that's probably not what you want, right? You don't want to change the memory location of mx to like an integer called 50 because that would not do what you wanted it to do, right? That would be an example of code that doesn't do what you wanted it to do. But when I did sas ampersand y, it wasn't initialized, so it's not an int yet. It points, all it's saying is create a variable that stores a pointer. That location would point to a pointer. That memory would point to an integer. But it would not be hooked up yet. So it would just point probably to null or who knows what value it gets initialized to. It's just like an integer. If it's uninitialized, it's just garbage. data, but the program would try and read it as a pointer, as a memory location. Okay, and then one more down here. So again, the asterisk, but not a declaration this time, at a variable, with a variable, before a variable means, sorry, before a pointer specifically, get the value of operator gets the value of a pointer. So think of it as following the pointer. Okay, so that means so let's say I've got something like this, right? Well, no, yeah, let's say something like, let's just say I've got, well, let's do this. Let's do this. I just want to make sure that this is nice and separated. So int x equals 5. My pointer is assigned to the address of x. All right. Then what is this going to equal? Oh, fantastic, Panda. Fantastic. Let's let other people's answers come in as well. Yeah, beautiful, beautiful, beautiful. Well done. You follow the pointer, right? Because we said that my pointer points to the memory location of x. So my pointer stores whatever memory location this integer is located at. Asterisk my pointer is going to be the value of, whoops, that memory location. So it's going to follow it to 5. So does my pointer equal ampersand x? I don't understand your question, SB, but that's pretty much my cheat sheet for you. Export. Let's export it to a PDF. I'm going to give this to Tom. Whoops. And hopefully he can share it all with you. Does that look okay? That looks pretty good. Okay. I think that's a pretty nice way of sort of summarizing it all. Any questions or anything? And SB, if you want to rephrase your question, that would be, how do we assign a value to a pointer if we declared it a while ago? How would we assign a value to a pointer? Pretty simply, actually. We would just say the value of my pointer is now equal to 10. So we can also use this value of I guess, yeah, gets or changes the value of a pointer. Does that answer your question? So as long as you have the identifier of the pointer, you use the asterisk, that gets the value of it, and then you can just change that value. Very powerful thing. No, 10 is the value. Remember, the asterisk is the value of my pointer. So we're changing the value, the actual integer that my pointer points to. It's the variable's value, exactly. If we didn't put the asterisk, that would be changing the memory address that it's pointing to. What does the value of operator means? It means if you've got a pointer here, in this case, right? If you've got a pointer here called, oh, let's do this one. My pointer, right? The value of operator is going to read the integer 3. It follows the pointer to the underlying integer. That's what the operator does. Why does my pointer... Oh, it doesn't equal 10. I'm assigning it to 10. Changes x to 10. Because there's only one... It's an assignment statement. This is an assignment statement. And this is annoying me that it's out of line. You got it? Awesome. Cool. SB says, so if we do this, right, like if we assign 10 to the value of my pointer, does x also change to 10? Absolutely. Absolutely. Because you're going into the guts of this variable x and you're modifying it. Okay, a few questions coming in. So if we assign my pointer to 10, yes or yes, what can you do with int asterisk x? So like here, you can point to an integer. Which is exactly what we're doing here. Or we can say it equals the... in this case, it wouldn't actually work. I might have to... We can say it equals that. Or we could say... is equal to the address of x. Right, these are both equivalent. And in this case, what it's going to do is make... I don't really have room for it. I could put it here. Or actually, I could... Get rid of that. This is looking a bit annoying. Oh, you guys probably get the idea. I'm struggling here. I'm just not going to hook it up. But we can also get the address of x and assign it to the value of x pointer to. Whew. All right, I'll re-export this. Okay. Sorry, Tom. Oh, what did that just do? Come on. Yeah, replace. Okay. All right. Okay, we better move on. But if you're still in doubt, that's okay. Go watch the Monday's lecture again if you need to. The other thing, actually, now's a good time to mention it. That's not what I wanted. Here. Who's been to the help sessions so far? Has anyone been? So if some of the pointer content that we're talking about is causing some confusion, one of the best ways to get clarification, help, one-on-one help, is to go to one of the help sessions that we run. These are both online and in person. So all you have to do is go to this website. I'll send you the link. And you can look, okay, there's a face-to-face session on this time slot on Tuesdays. There's an online session on this time on Wednesdays. You can attend, there's a queue. You can get one-to-one help from one of our fabulous tutors. You can see we have a pretty extensive timetable every single week, including next week, which is Flex Week. So I really, really recommend that you attend help sessions. If you can even just go and ask some questions on pointers, for example, or you can bring code that's not working, anything like that. Cool? So I just want to point this out, right? Take a note of this URL. If you need help, this is one of the best ways to get it. Okay, it's 10:47. Let's do our pointers Kahoot. We haven't done that yet, so hopefully we'll be checking how much you've been paying attention. I've not seen the actual Kahoot. Tom made it this morning. Thank you, Tom. I am clicking a link. It's not opening though. Oop, there we go. Now it's decided to do it 3 times at once. Oh my God. Continue for free. Okay, got it. What's going on? Yeah, Tom, you might need to check that, fix that PDF, please. Okay. Thank you so much, Tom. Okay, streaming these lectures is so many systems that go into it. What did I want to do? I want to turn Spotify, pause, open up the Kahoot. Apparently that's not playing anything, but that's okay. All right, let's go. All right, there is some music. Nice. All right, while you all join the Kahoot, I'm going to really quickly get some water and then we'll get it started. Cool? Okay, that's going to be a problem there. Maybe I'll just turn this off. Okay, good to go. All right, let's go. Thank you again, Tom, for making the Kahoot. Let's do this. What happened to the music? So what is a pointer? A variable that stores a non-memory value, a variable that stores the memory address of another variable, a variable which stores a copy of another variable's data, or a variable which is another name for an existing variable. Oh, fantastic work, everyone. So pretty simply, a variable that stores the memory address of another variable. Although technically not necessarily the memory address of another variable, it could just be of other memory address that isn't actually a variable yet. But you're not, yeah, this is right. So sorry, Tom. The questions are good. Okay. Nice job. You guys pick hilarious names. So how do we create a pointer to an integer? Good question. Good question. This is testing your syntactical knowledge. How do we create a pointer to an integer? Which one is it? I guess it's, okay, yeah. This is a good one. And you got your handy cheat sheet for quick help. Okay, 14 people said int my pointer, which is all correct, equals my int. So what this will try and do is assign the memory address of my pointer to be, the integer 50. That wouldn't be what we wanted to do. This is more correct. To get the address of an integer, right? Because we want to point to an integer, get the address of that integer and assign it to our integer pointer. So this is absolutely correct. So congratulations to the 31 of you who got that one. Jake Renzella is the highest climber. Interesting. Toyota Fortuner. I assume that's a type of Toyota. How do we dereference a pointer and change its value to 3? Great question. Oh no, my Kahoot's slightly cut off. How do we dereference a pointer and change its value to 3? This is my new water bottle. Oh, you can't see. I've turned my camera off. What am I doing? And you guys are focusing. I'll show you later. Enjoy my ASMR content. Okay, good work, everyone. Yeah, value of or dereference. That's a good point. I don't think I've called it that yet. But yes, this is good. Get the value of a pointer and change its value to 3. That's absolutely correct. The asterisk always goes before the identifier in every case, so it's not blue. That's just a simple syntax thing, and these ones are not correct. Good job. Pointer hater is the hardest. Pointer hater. Oh, come on. But you like your Kahoot points, huh? A pointer itself has its own memory address, true or false? A pointer itself has its own memory address. I want to be a game show host and just do C-related questions. I don't think many people would watch. Well done, absolutely. If we look back at our diagram here, remember, even a pointer has a memory address. A pointer has a memory address. A pointer has a memory address. Congratulations to those 40 of you. Oh no, we lost top spot. Good work to in. Last question, true or false? A pointer can point to any variable type, including something like a struct. A pointer can point to any variable type, including structs. Yep, absolutely. We can point to anything, including void, which is kind of wacky. So we can kind of point to literally anything. Okay, congratulations to R is greater than debris. I'm assuming that's something to do with math courses that you take. In, don't know what's going on with your name there. And Huya, 4472. Very close though, very close. Tim living front and Jay runners up. Congratulations on our final Kahoot together. Oh, how sad. So would you all watch my programming game show? Right into like channel 9 or something, get me a spot. Ooh. Yeah, well done everyone. Good, thank you Tom for making that Kahoot. Okay, let's take 100%, great job Potato. Let's take 5 minutes, sound good? And then we're going to just write some code together, some 2D array code. Can't wait. See everyone in 5 minutes.
So that's from the HDR perspective.
Well, there's a real conversation, and right, and they're going to take us through.
So we'll get towards. Would you like to?
Welcome back, everyone. Whoops. I was just going through some emails. Okay, so what I propose, you guys let me know if you disagree, is that we just get straight into the 2D array program that we want to write so we can maximize our code writing time rather than going through. There's some basic lecture slides here, but you've seen basically all of it. We have an array, right? We can have a 2D array, which is an array of arrays, and we can store structs in our arrays. And what we're going to do is put these concepts together to build a program utilizing 2D arrays that we'll build together, basically. Does that sound good to everyone? So I'm going to quit that. I'm going to quit this. I'm going to quit that. Make this a bit smaller. Whoops, I don't know what this is. Apparently I'm not setting enough keyframes to YouTube Live. Don't know what that's complaining about, but let's ignore it. Okay. So we're going to make a program today that's going to be ice cream hunt. Whoop. Ice cream hunt. So we're going to have a player navigating around a 2D grid trying to find ice cream. Okay. So there's going to be some user input, printing the grid, and we're going to need some way to put an ice cream, basically. We'll see how much time we get to and what we can, what we can do. So who can tell me what the first step might be here? I mean, other than like, I'll put Jake Renzella, 2022. We'll put more details there. I'll get the basics in there, but what would be a good spot to start? Can anyone tell me? Declare the struct. Or the array in its dimensions. Absolutely. Like, let's think about the data structures that we're going to be dealing with today. The keyboard is so good, it's distracting. I don't know if that's a good or a bad thing. Yeah, absolutely right. So we know that we want to have some sort of game world, right? And there could be like ice cream at a location, and we could have a player at some other location. It could be something like this. And we want to be able to move around finding and trying to find the ice cream. And maybe we can like hide where the ice cream is. So we know we need this player, and we know we need this grid. So we could start with the player, absolutely. So the player is going to be a struct. We'll call it player. It'll have a character, which will be like the, let's just call it the name. It'll have a position, which is going to be the pos x and the int pos y. Right, so the x just being, 0, 1, 2, 3, or 4, and the y being 0, 1, 2, for example. That'll be the struct, semicolon there. And we could also have the actual ice cream. It would also have a name, let's say it would also have a position X and a position Y. And we could give it something like an enum to be like well, no, never mind. We need to make our enum first. Enum ice cream type, which could be something like dairy, I don't know, soy sorbet. I don't know, what other ice creams are there? You guys can tell me. And then we can have this, we can just call it type. So we can have different type of ice creams. In fact, let's not have a name. And we'll use the ice cream enum to determine its name dynamically. That'll be cool. That'll be cool. You guys can let me know some other ice cream types. So we've created our structs here, and we've created an enum. So some extra data that we'll just put into this struct. And then we can just sort of just get started in our main function here. And probably the first thing we want to do is make the actual grid. Right, so we're going to call it grid. It's going to be a grid of integers. It's going to be a 2D array. Now, here's something else that we're going to need to define how big our grid's going to be. We can just do something like 5 by 5, but it's probably really good then to, you know, say hash define num cols is 5. Oops, that should all be capitals. And number of rows is 5. And it'll be num rows here and num cols here. Is to 0. So can anyone tell me how we would initialize all the elements in this two-dimensional array to 0? Karma, yep, very nice. Something like this will initialize is shorthand to initialize everything, all elements to 0. Whoops, whoops. Something like that. Very good. Good job, everyone. All right. Something else that we're going to want to do, or, you know, you guys can tell me, but otherwise we'll take forever, is print our grid, right? So that we can see the representation of what's going on. So what we'll do, we'll have a procedure here called print, you know, print the grid. Now, who can tell me what the parameters of this procedure is going to be? Right, so we're going to need to pass this grid. We might need to pass some other things, but for now, let's just pass the grid. So what are the parameters going to be? What do we need? What information do we need to give to print grid? Grid, but can I just say grid? Like, is that going to work? You're right, I want to pass grid, but how do I write the actual procedure that accepts that? Int row, int col. That would just be 2 integers. I don't know if that would be quite enough. Yui says, oh, interesting. I pointed to a grid. That's not bad. I like pandas answer a bit more. Nix also works, but pandas is a bit more precise because it's giving the numbers and the size of the array. So I like this. So it's going to be something like this. It's a 2D array of integers passing in the number of rows and the number of cols. Yeah, exactly. We could do that. It's the same sort of thing, but this is just a little bit more precise because we know how big the array is going to be. Absolutely. So for now, we can probably just leave it at that. And then down here, we can say, we can try and understand our logic for actually printing out the grid. So we can do this with some while loops, or we can do this with some for loops, but basically we need to loop through all the rows. Each time we're getting to a row, we loop down and print the column, print the columns. So we can say int row is equal to 0, while row is less than grid. Oh, sorry, the number of rows. Whoops. oops, something like that. So this is going to loop through each row. Every time we do that, we want to say int col is equal to 0. And while col is less than number of cols, we get to the actual body here. And we're going to printf %d will say, remember we're storing integers with a space at the end of it, and we're going to print grid at row col. Something like that. We need to increment, so this is going to be here row plus plus, and this is going to be here col plus plus. All right. So this is just a nice little basic test here. Let's just do that. Then we'll print the grid, we'll pass in grid, and we will compile this code. Remember, again, I'm using GCC because I'm running locally. You would use DCC on VLab. So that compiles okay, apparently. Let's run this, and it's not really what we want. Because every time we loop through all of the columns, we want to print a new line. So I guess that would be here. I'm just thinking if this is actually written the wrong way around. Yeah, that's nice. Yeah, that's good. That's good. Yeah, so each time we finish a row, we print a new line. Perfect. Yeah, good job, Ayush. Good catch. Okay, and this is a pretty nice looking grid. So that's basically what we wanted, right? Something like this. We don't have the player in there. We don't have the ice cream in there. Nothing like that. What we're also going to say is essentially that 0 is unexplored. Oh my god. Oh my god. Come on. Unexplored. We'll say 1. Maybe we can say X is explored. And we can say something else for ice cream. We can do J for player. And then something for ice cream. We'll see. We'll figure that out when we get there. So by default, though, all the tiles will be unexplored. So that's really nice. All right, we've got a pretty good basis already of our program. I'm just looking at my notes here. Probably a good time to, and please let me know if you're following along and writing code along and I'm going a bit too fast, you want me to slow down a bit, please just let me know. Or if you just want to watch, I can maintain this pace. You guys tell me. At any time, just type, slow down, speed up. We can do that. All right, why don't we make the player now? So it's struct player, right? Was that player there? We can call the player Jake. Yep. Well, no, let's just call it my player. Yeah, absolutely. I'll share all the lecture code. My player.name. We can call it, I don't know. That's a bit self-involved if I call it Jake, isn't it? What do we call it? I'm going to call it Sasha. Why don't we call it the player Jasha for Jake and Sasha? Team Jasha. Okay. Semicolon. All right. My player dot position X. Where do we start off? Why don't we do... We could do 0, 0. We could do 0, 0. That's fine for now as well. Okay, was that everything in the player? Yep. So that's created the player. Now, then the question is, we could also do the middle, but then the middle's hard because if it's an odd number, you got to like figure it out. Let's just do 0, 0 for now, right? And we can do things later. Oh, you're right. Sorry. It's a character. We'll just do J then. Yeah. Sorry, we haven't done strings yet. Whoops. Be cool if you could do emoji. See, that's a good reason why name is probably a bad... See that? Like, when you pick a bad variable name, you cause bugs. Pick the best variable name you can. It makes you... If I had called a player initial or something like that, I would not have made that mistake. So good job on catching it yourself, but that's really good demonstration of why identifiers is one of the most important things. Honestly, I write a lot of code. Well, it's all relative. I don't write code full time anymore, but I still write a fair bit of code. One of the things that I agonize the most over is just what to name my variables and identifiers. Because you need to write code that if someone picks up in a year, a month, they can read it and be like, oh, that's exactly what Jake meant. Yeah, we could put a car array. That's how we would do it. And that would be a string. I don't know have you covered strings yet in this course? But for now, let's just keep it simple. So we have this player, but that means we need to tell the grid, right, how to, the grid needs to know where to print the player. So one thing we could do is just pass it in. So other than just passing in the grid, we can pass in a player, my player. In fact, do I need to do struct there? I think I do. Yep. Because we didn't make a type def, and this is my player, and that means we'll need to update it here too. Okay, so nothing new there. That's nice. Now, so we know when we're printing where this player is. So what we want to do is we do that, and then we say, and also this is really annoying me, so let me just... Whoops, it's set to the wrong, let's just do 2. Whoa, yeah, that's clearly what I wanted. Okay, what is going on? If row is equal to my player dot, I guess, no, the X would be the columns, the Y would be rows. And col is equal to, we'll do the same thing, my player dot pos X. We don't want to print this, we want to print, for now let's just print the initial, oh no, we want to print my player dot the initial, and it's not going to be that, it's going to be that. Otherwise, else, we'll print the actual integer. Yeah, we could do that SB, but we're not going to. So let's see if this works. Okay, that's perfect. That's what we wanted, right? So if the col row is the player's col row, print the initial. How's that sitting with everyone so far? thoughts, queries, concerns? Very well. Excellent. Okay. So that's that. Now, what could we do next? We could get the player moving. That's probably a good one. Now, we'll do this up in main. So that's exactly what we're going to do now, Nathaniel. That's exactly what we're going to do now. So this created the struct, this created the player, this printed the grid. Now, we need to get some user input from the user to move the player up and down. So we can say something like printf, where would you like to move? And we need to read in something from the user. So the way we can do that is with scanf. So I'm just looking at my notes here. What I wanted to actually figure out. So C scanf. How do I get the actual up arrow? No, never mind. That's too hard. Okay. Oh, I know what we do. Let's do WASD. Let's do that. Right, so WASD to move around. So int scanf, int direction to move is going to be equal to scanf. And here we have just a bit of sort of weird C code that we need to write, excuse me. We get a %, so you get a character in from the terminal because we read strings and characters from the terminal. And we're going to put that in Okay, I see. So we're going to need a couple things. We're going to need the car direction to move. And then this will be the number returned. And I'll explain what's going in there. This is going to be scanned into direction to move. So read in a character, it's either going to be, hopefully, WAS or D. Store it in direction to move. Scanf, right, also returns the number of things that were entered by the user. So let's document this a little bit. So read in a character, hopefully, hopefully WASD. Store it in direction to move. Return the number of elements entered. Right, something like, so that looks pretty good there. Here's the sort of magic, not magic, but while the number return's not very nice, it's the number of input, number of items input, let's call it that. So while the number of items input is not equal to EOF. Now EOF is a special, means not the end of the line. It actually stands for end of file. Have you seen this before? Has Sasha covered this before? Yes, okay, fantastic. So I don't need to go too much into it. Fantastic. So it just means, did the user input something? That's all it means. Did the user input something? Yeah, this is where you would use Control D, which would signal end of file. exactly. Okay, so we have a few things that we need to do here. So we've just moved. So the first thing we need to do is set the player's current position to be whatever we said would be for explored. Or X, we said. Oh no, well, we can't do X because it's an int array. But this could have been a character array, for example. In fact, that may have been better, but we'll just do ints. That's fine. So set the player's current position to be 1 because we're already at that position. Does that make sense? So we've just moved, but before we actually move, set the player's current position to 1 because we're about to move off it. Alternatively, when we go somewhere, we could set it to 1. In fact, that might be a better way to do it. This will also work though. We'll play around with it later. So how do we do that? Well, we've got our grid. And what we're going to do is say that my player, I think it's the Y first, is the row, yep. And the player's X, so the player's position is going to be equal to 1. Right? So we take the player's position, we modify the grid itself, and change the value at that element. So any questions on that line, please let me know. Okay. Then we can actually move the player. So if the direction to move is equal to W, we'll do W like that, lowercase, then what do we do here? Can someone tell me? So we've just moved up. How do we do that? Validate the move. That's interesting. That's interesting you say that. Let's validate it later, but really good. So pos x plus 1. So let's think about it. How do what do I do? I already closed Figma. Oh no, I didn't. Let's think about this, right? If we've got this is, oops. Okay, hold on, what's chat saying? So shouldn't position X be the row? No, X is the column, because it's like, so it's which column it is. Y is the row. This is probably confusing. This probably could have been column and row. But X and Y is the same sort of thing. So I think that's right, because it's row, column. Row, column. Yeah, row, column. So think about it. So what would the row, what are we changing here? No one's actually said it. No one said the correct. I wish I just had like an easy way of doing this. Of like drawing this. What's this do? How do you know that the +1 moves up the grid and not just right? Well, it depends what we change, right? It depends if we change to the position Y or the position X. So what do we want to change here? Well, think about it, guys. Think about it on a mathematical plane. This is X, yeah? This is Y. We're moving up. Yeah, good job, SP. Yeah, good. So what are we going to do? We're going to move this way. We're going to move this way. Panda, setting it to 1 shows that we've been at that position. That's all. Setting it to 1 is, this is wrong. 1 is explored. It just means we've been at that position. So that when we leave, we'll draw it at 1. Yeah, we're subtracting 1 from I, exactly right. Because we want to make I higher, and 0 was at the top. So my player dot position Y minus minus. Yep. Okay, then we basically do the same thing else if the direction to move, in fact, so W, we'll do A next. So A means you're moving left. So what are we going to change here? X minus minus. Perfect. Very good. Very good. Very good. Good job, everyone. Now, what would you fill in the rest now while I do this? WASD. So what's S going to be, and then what's D going to be? Y plus plus. Yeah, that's right. That's right. And then X plus plus. No. Oh, yeah, correct. Yeah, exactly. Good. All right, and that is that. All right, and then in our loop, the last thing we're just going to do is draw the grid. What do I do? Print. I call it print grid. Print grid, we pass in the grid, we pass in my player. And hopefully, if everything worked okay, it might actually be good as well to just do a printf. Didn't I already do this? Oh yeah, here. Put this in the loop so that it loops every time. W is to move up. W is to move up. The reason, I don't know if if you play any games, or this is not working, but W is up, S is below, D is to the right, and then A is, you just look down at your keyboard. And you'll see. Okay, we've got some errors here. What have I done? Line 75, I've got an error. Function definition is not allowed here. Okay, did I forget a closing brace? Yes, I did. That's all. Is that all? Let's clear the terminal. Let's compile it. That worked great. Let's run the program. Now, hopefully if I go S and press enter, whoa, that wasn't good. That was not good. So what have I done wrong here? Int number of items is equal to scanf %c direction to move. That's fine. While that is not end of file, do that, print it. Oh, I see. Okay, so the problem here is that I didn't wait to, I didn't scan in again. Exactly right. Good job. So I'll do that here. I'll print the grid, then I'll actually print the instructions again. In fact, let's not print them there. Let's print them, let's print them here, and then let's print them here. Yeah, good job. We could also do that as well. That's also a good... I think what we'll do is we'll write this code, we'll get it working, and then we will clean it up. So if I press S now, that did not work. Oh, now it's sort of working. But that doesn't look... I mean, so it's working. But something's gone funky, right? Oh, hold on. Is it just... I know what's happened. When I printed this, I need to print a new line. So I go down, I go right, I go down, I go up. How good does that look? That's pretty cool. Now, C, clear. Something else we can do. That's really cool. How hacky do we want to get today? How hacky do we want to get? Do we want to get a little bit hacky? Again, so this would not be anything that's like examinable in the course. A little bit hacky, just okay, a very hacky. So what we can do is hash define a macro which is called clear screen, and I'm just going to copy what it's actually going to do from Stack Overflow, and I'll explain what's going on there. But every time we loop, let's print the grid, let's clear the screen, and then print the grid. Do you see that? So it's this actually clears the history of my terminal so that it looks more like an interactive game, right? Looks so much nicer than when it's just shifting down the screen. This is really hacky. You could probably just make a function. You could just call this itself, but like this is not very obvious. So this is like a nice little shorthand for it. Okay, that's really nice. I'm happy with that. And I'll put a little comment here. This is hacky, not examinable. Okay, just to be really clear. It is nice. Yeah, it's really nice. Okay, we can do more stuff like that. All right, so we're moving around. We've got 15, 20 minutes left. We're moving around. Okay, here's a problem. Someone identified this problem and they said validate, but what happens if I go up at this point? Well, I can go off the grid. So something's just gone, completely wrong there. So we don't want that to happen, right? So how can we protect the player from moving off the screen? There's a few ways we can do it. The way I like to do it is to say, if we want to move up and we're not, that the my players dot position y and my, well, let me not do that. And the position y is not equal to 0. Is that right? If it is equal to 0, is that right? I think that's right. Sometimes these double ands and stuff. Yeah, see now I'm going up, but it's not moving up. So only move up if you're not at the top. And you can just simply do that for all of them. So only move left if the myPlayer.posX is not equal to 0. That's the same. This one is going to be the numCols, right? And this one is going to be, whoops, that the y is not at the num rows. Let's compile that. So can I go left there? No. Can I go down there? No. I can go down, so something's gone wrong there. What did I do wrong? S is wrong. No, that should be Y, right? So then what have I done wrong there? And then D should be X. Is that right? Yep, that's not right either. So left is right, up is right, so it's down and right. So down is, so X, W, oh, I think I see what you're saying there. But max call is 4. So X, Y, 1, 2, 3, 4, 5. Yeah, we just take 1 off. Good catch there. Can I go up? No. Can I go down? No. Can I go left? No. I can go right, but I can't go there. Nice. Cool. That's looking pretty good. Alrighty. Any questions so far? What we can do now is put the ice cream somewhere. We can do something else that's cool for that. So what I'm actually thinking of doing is blah, blah, blah. We do this. Let's have a procedure called initialize the game. We pass in the grid. We pass in the player, and we pass in, we also need to make a struct now. Struct, what did we call it? Ice cream. My ice cream. We'll say that the my ice cream dot position X is equal to, let's just say 2. The Y is equal to 2. And the type is going to be dairy. Oops. I think these should actually all be capitals. Is that right, Tom? I think that's what we've agreed on. Can someone check the thing there? But basically all of this initialization code, I think it would be really good to put it in init. Yeah, all caps, perfect. To put in an init game, we pass in there and we pass in the ice cream. So I know I'm going a bit fast here, but it's just because otherwise we'll run out of time. And basically this won't work, will it? This won't work because we would need to return too many things. So there's ways we can fix that by putting it all in a struct that we return, but for now, actually, let's just not worry about it. Sorry for that misdirection there. Okay, but we've set up the ice cream. When we were drawing, we will also check if this, else if the row is equal, well, we also need to pass the ice cream in here now. Okay. Right, so now, just like we checked if it's the player, if the ice cream Y and X, is matching, then let's print what character would we use for ice cream? Well, actually what we could do here is say if my ice cream dot type is equal to dairy, and we've got lots of if statements here, we can print D for dairy, right? And you can imagine that we could do, you know, else if something else and blah, blah, blah. Okay, this needs to be lined up to our declaration here. Cool. Okay, we print that, and we also need to pass it my ice cream, and that's going to be the same when we print the grid down here. Beautiful, and let's see how that works. So I go down, 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 right, right. And then we can see that our ice cream's there. How cool. So then what should we do if we are on the same position? So can I ask another thing? How are the ones printed out after J moves? Great question, Nathaniel. It's really simple. On line 71, before we move to another position, we set the player's position on the grid to be the value 1. And then we pass that grid to print grid, and we just print the grid's value. By default, the grid starts at 0, which was here, but we change it if the player was at that position, so it prints out a 1. Does that answer your question, Nathaniel? Cool. All right, so then there's so many things we could do. What do we want to do if we, if we arrive at the same location? We could end the program, but that's a bit sad. We could just print something. We could do that. So what we could do here. Is that what, do we want to do that, everyone? Have I gone a bit too fast for people? We could have a points variable. Oh, that's a good idea. That's also a really good idea. For now, I think we can just print out a message. But yeah, you could, what you guys should do is take this code, play around with it, get it working, and then you can do heaps of stuff like that. Oh, you know what we could do actually? You know what we could do? Let's not draw. Hold on, let's quit this. Let's not draw let's not draw where the ice cream is unless we find it. Does that make sense? So this is if we find the player. This is if we find... So this is... Okay, so yeah. Let's not do this. Instead, let's say if my players.posy is that posy, and my players.posx is equal to the ice cream's position, then print the letter D. Does that make sense? Otherwise, it's just gonna print 0, right? So now we go down, we go right, we go right, we go right, we go right. Where's this ice cream? Where's this ice cream? Whoa. That's not what I wanted to do. Why did that happen? Oh, okay. Hold on, what's happening there? What's happening there? If the player's position and the ice cream's position overlap, Oh, because it's always overlapped. And then it goes to the next position. Okay, so what we need here. Does anyone know how to fix this? Anyone got any ideas? That's a funny bug though. It kind of looks cool, but it's not intended. So we should fix it. Yeah, that's exactly right, Natalia. Exactly right. We only want to print the letter D if the col is equal to the my ice cream dot pos x and the row is equal to my ice cream dot pos y. So we only want to print it for that one sort of iteration, right? Let's see there. No, that didn't work either. I think, but maybe I just got these mucked up. So no, that should be right. So if the column is the ice creams X and the row is the ice creams Y. What's going wrong here? Can anyone tell me? Maybe it's... is it prioritizing printing the initial? No, isn't it doing this second? It's doing the D second. Why don't we do printf col is %D, row is %D, oh, I can't do that there. No, that's not helpful. Yeah, that's not helpful at all. Let's... What if we do that there? Nope, that's also not helpful. Let's do it here. Okay. No, that's not what I wanted to do. Because it's if print J then print D. Tom, do you have any ideas as well? Well, you know what we could do actually? We could debug this properly. How about we do that? You guys probably haven't seen this before, I'm guessing. Okay. Oh, that's annoying. Okay. All right. All right, so this is running my program and I'm setting breakpoints. I don't know if you've seen or spoken about debugging before. It's really powerful. It's going to let me see what's going on. So we can hover over these values and see, okay, we're starting off, row is 0, column is 0. How cool is that? The player's position is also 0, I think, and the Y is 0. So this is going to be true, and it prints out J, right? This might be, I don't know if actually this is going to work because, you know what, let's do this. Let's set the ice cream also to 0, 0, so that we don't have to move and see what happens. All right, so this is what's going wrong. So that matches up and it prints, well, that's probably the problem. We've already printed the J. So I think maybe these just need to swap. So whoever said that before, I think you were right. So if that's the case, then you do that. Else, if there's no ice cream there, print the player. And if there's no player or ice cream, print the column. Yeah. There we go. So whoever said it, SB, you were spot on. I should have listened to you more. Apologies. So what was happening, it was coming to the position, and the first thing it was doing is drawing the initial. Then it was like checking the if statement again, but it had already drawn, it had already printed. So by just changing the order, we sorted it. But good job, SB, on catching that. Okay, and this is probably a nice place to leave it. Debugging, there'll be a lecture on it later in the term, but that was a good example of sometimes why you need it. And this is a pretty good little 2D array program, I think. Whoops. Oh, you can do that. That's cool as. Because it just keeps scanning it and does it multiple times. Nice. How cool. All right, I know I went pretty fast through that, but this is the type of program where you'll want to grab the source code yourself and have a nice play with it. It's 12 o'clock. Thank you all so much for having me in COMP1511 this week. I hope you had fun. I hope you enjoyed my, what do we call it? My sabbatical, my visit, my fellowship with you all. We'll upload the course code. Thank you, Tom. I'll send this to you right now. Good luck with the rest of term. You're all going to kill it, I promise. Well, hopefully. No, you're all going to kill it. Good luck. Enjoy programming. Enjoy. Sasha's back, not next week, because next week is the midterm break, but there's help sessions and there's a lot of other stuff running next week. And then the week after, Sasha's back with the lectures. So thank you for having me. I had a really good time. I hope you did too. If you've got questions about the lecture code or anything like that, chuck them on the forum and I'll keep an eye out over the next couple of days and answer the questions that you might have, okay? But otherwise, have a great week. Look after yourselves. Flex week next week. Try and recharge. I know you've all got studies and things that you also still need to do, but try and recharge a little bit. And like I said, on Monday, I teach COMP1531 next term in T1. Which is the second one of the follow-on courses that you may take if you're continuing on computing or software engineering or something like that. So I may see some of you in T1 in fundamentals of software engineering. But otherwise, I'll see you all next time.